Can You Taste the Difference? By Akila Triggs and Rachael Bussey. Brief description. Many people often debate whether or not water truly has a distinct taste. We conducted a study to test this theory using two brands of water, Deer Park and Great Value. We hypothesized that among our sample size of 30, less than 30% will be able to taste the difference. After compiling our data, we conducted a two-sample z-test to determine if our hypotheses were accurate. We chose this topic because many people believe that water has a constant taste no matter the brand. We wanted to know if people could actually taste the difference. The study isn't necessarily important, however, we wanted to find out the results. We would recommend that another party conduct the same experiment because ours only used the school's population. We collected our data by setting up a table during all 3 lunches and allowing students to come to the table. A convenient sampling method was used. We chose a sample size of 30 because we thought that was a sufficient number of people based on our school's population. We successfully collected data and was able to accurately perform our test. There were few people who wouldn't take the test, which somewhat hindered us from quickly collecting our data. Given the fact that we allowed people to volunteer to come to the table and conduct our experiment during lunch, we have a biased convenient sample. Some sources of bias that we couldn't avoid was if the subject had eaten something prior to tasting the water that would have had an effect on the accuracy of the data and changed the taste of the water. If someone was to repeat our study, we suggest that the sample size be increased and an additional category of undecided be included in the taste responses. Test time. This is a one sample proportions z-test. Step 1. Our P is going to equal the proportion of students who can taste the difference in water brands. Now we're going to write our H naught and our alternative. Our H naught is going to be P equals 0.3 and our alternative is going to be P is less than 0.3. Step 2. Now we're going to do our conditions. SRS we're going to assume robust. Normality is going to be NP is greater than or equal to 10, or in parentheses 1 minus P parentheses is greater than 10. And as you see, this does apply. Now we're going to do independence, which is population is greater than or equal to 10 times N, which is 300, so it does apply. Step 3. Now the hard stuff. Our formula is going to be Z equals P hat minus P over the square root of P parentheses 1 minus P divided by N. Your P hat is going to be 0.7, your P is going to be 0.3, and your N is going to be 30. Now it's going to be 0.7 minus 0.3 over the square root of 0.3 times 1 minus 0.3 over 30, which equals 4.781. Use your table A to find P. Once you find your P on your chart, P is going to equal 0.999 repeating. Our alpha level is 0.05. Step 4. For our conclusion, we're going to fail to reject because our P is greater than 0.5 and conclude that the proportion of students who can taste the difference in water brands is equal to 0.3. A type 1 error is when you falsely accuse. So when someone says they could taste the difference in waters and we said they couldn't, we're falsely accusing them, and that could alter our results as a consequence. A type 2 error is when someone gets away with a lie. So when someone says that they could taste the difference in water but they really couldn't, that's also altering our results as a consequence. Thank you for watching.